Alright students, welcome back to this video segment. In this video segment we shall continue with finding the GCD of two integers using the Euclidean algorithm. So please, it's a continuation. So here in this video segment we shall solve these and we shall also kind of have an overview of the Euclidean algorithm before we end this video. Okay, so remember in the Euclidean algorithm there are some things you need to know, and first of all you have to know that GCD of A and B will give you the GCD of B and R. Okay, A is the dividend, B is the divisor, R is the remainder. Just know that. Okay, and the next one is that A is equal to BQ plus R, where A is the dividend, B is the divisor, Q is the quotient, R is the remainder. Then you should also know that 0 is less than or equal to the remainder less than the divisor B. So this is kind of what we said in the first video. So you just need to know this and pretty much okay. And like we said, the dividend is always greater than the divisor because we don't want a fraction. We are dealing with integers, so our dividend will always be greater than the divisor. Know that also. Alright, for the GCD of 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. So this is A and B. Now this is B is greater than A, so we swap it. We swap. So this is GCD of 5, 4, 3, 2, 1. 1, 2, 3, 4, 5. Okay, I get my simple adding machine. Simple adding machine. Now we now divide just like you do in the fraction, like we said the other time. You divide 5, 4, 3, 2, 1 will be 1, 2, 3, 4, 5 times what? Let's see. You do 5, 4, 3, 2, 1 divided by 1, 2, 3, 4, 5. Gives you 4.400 something. So you just write 4. The integer value. Just bring out the integer value. Then you now do, okay, 1, 2, 3, 4, 5 times 4. It gives you 49380. Then you subtract it from 5, 4, 3, 2, 1. It gives you 49 plus 4941. Remember, this is the B, is the divisor. Of course, this is your A, your B, okay? This is now A, this is B, this is Q, and this is R. Just know that the dividend is equal to the divisor times quotient plus the remainder. So I'm kind of explaining this to, add to your knowledge of this first one. Alright, then the next thing, remember the GCD of A and B will give us the GCD of B and R. So what we want to do is this B and R, right? We bring this over here. 1, 2, 3, 4, 5, our B and R. Now our R here, okay, 4941. Because this works in this principle. It just works in this principle that of course GCD of 5, 4, 3, 2, 1, 1, 2, 3, 4, 5 is equal to the same thing as the GCD of 1, 2, 3, 4, 5, 4, 9, 4, 1. Okay, I'm explaining this very well now so that you don't get confused. Okay, so let's finish this. So let's find the quotient. You divide this 1, 2, 3, 4, 5 divided by 4941. It gives you 2.498 something. Get the integer value 2. So times 2. Then plus. Now you now check 4941 times 2 gives you 9882. Then you subtract it from 1, 2, 3, 4, 5. Gives you 2463. 2463. So in this case now, this is now, of course, your A, your B, your Q, and your R. So the B and the R will now turn back. Okay? Yeah, this is now your new stuff. That's the way it goes. It continues that way. So this is now 4941 equal to, you bring this over here, 2463 times, okay, we continue our, we do 4941 divided by 2463, it gives us 2.006 something. You bring the integer part, okay, then you now do 2463 times 2, it gives you 4926, and you subtract it from 4941, so it gives you 15, right? So I'm gonna use here, this is the same as GCD of 4941 2463. Okay. Now I'm running out of space, but I'm gonna continue like this. I'm gonna start from here. Let me write it here. 4941 2463 times 2 plus 15. Then this becomes your B now becomes your A, which is 2463 equal to then 15 times what? So you now do 2463 divided by 15. It gives you 164.2. Get the integer part, 164. Then you do 15 times 164. Gives you 2460. Subtract it from 2463. Gives you 3. Okay? Then, of course, this is now GCD of 2463 and 15. Okay? Then you now bring your 15 over here. Of course, 15 is equal to, bring your 3 here. 3 times. So you now do 15 divided by 3 is what? 5. So plus 0. So once you now remember the definition of GCD is the greatest integer that can divide the two integers without a remainder. Without a remainder means the remainder will be 0. So you see that the remainder is now 0. So you now check the divisor. GCD means divisor, greatest common divisor. So if you check the divisor right there, the divisor is 3. At that point where is 0, check the divisor. Remember, this is dividend, divisor, quotient, and remainder. Remember that. Dividend, divisor, quotient, and remainder. So at that point where the remainder is 0, check the divisor, and the divisor gives you the GCD. So that means that the GCD is 0. The GCD is 3. I'm sorry. The GCD is 3. So this means the GCD of 15 and 3, and that means 5, and that means 3. 15 and 3. And that gives you 3. Because if you like, you can also say 3 and 0, which is 3, but this is okay. That gives you 3. Okay, remember that, you know, the divisor becomes the dividend and then the remainder becomes the divisor. This principle. This is the principle at which it goes. And when you now reach here, when you reach at the point whereby the remainder is 0, just check the divisor there, and that becomes the greatest common divisor. So 3 is the greatest common divisor of 54,321 and 12,345. Okay. I mean, now if you want to kind of do it for that, you will still end up at getting 3 as the GCD. Alright, now let's do the next one. I hope you understood this one. I spent some time trying to explain this so that I will make sure that you understand it. So you might want to look at it very well to make sure that you understand it very well, okay? Alright, let's do the E part. So we have E, let me check out this. GCD 1,540. Now we see that here our A needs to be bigger than our B, so we rewrite it 540, 1,000. Okay, so 540, you divide it 1,000 times what? Times, you do 540 divided by 1,000, and that gives you 5, right? 1,000 times 5, 5,000 minus 5 is the integer part. When you now do 5 times 1,000, it gives you 5,000. You now do 5,040 minus 5,000, it gives you 40, right? So this is your A, your B, your Q, your R. Okay, your B and R, because the next thing is that B becomes A now, right? B and then R. R comes over as B. So this is 40 times what? You now do 1,000 divided by 40. I think that gives you 25. So 40 times 25, then plus 0. You see? So at that point whereby the remainder is 0, you check your divisor. Your divisor is 40. So we can say that our GCD of 5,040, 1,000 is equal to GCD of 1,000 and then 40, and that will be 40. That's it. Now, if you know, when you have a multiple, you know, for that 1,000 is a multiple of 40, and you know that it's going to give you 0, now becomes evident that the greatest common divisor of both of them is 40. Alright, the next one. This one was pretty quick. It was pretty quick. Okay, we have a GCD of 9888, 60, 60. Okay, this arranged well. It's arranged well, so we go ahead. 9888 is equal to 60, 60 times what? Now we divide 9888 divided by 60, 60. Gives us 1. So 1 is the integer part. Gives us 1.6 something, but 1 is the integer part. Right, 1. Then you subtract that. 9888 minus 60, 60 gives us 3828. Right? Then we bring this over here, 60, 60, and then we bring this over here, 3828 times. We go ahead and divide 60, 60 divided by 3828. Gives us 1.58 something. So we call it 1, then plus. So we do 60, 60 minus 3828 gives us 2232. Right? So you bring this over here again. 3828 will be equal to 2232 times what? So you do 3828 divided by 2232 gives us 1.71 something times 1 plus, you bring the integer part. So you do 3828 minus 2232. And that gives you 1596. 1596. So you bring this over here, 2232 will be, bring this over here, 1596 times what? Let's divide it. So 2232 divided by 1596 gives you 1.39 some 398 something. Bring out the integer part 1 plus, you now subtract 2232 minus 1596 gives you 636, 636. Okay? So you bring this here, 1596 is equal to, bring this over here, 636 times, now do 1596 divided by 636 gives you 2.5 something. So get the integer part 2. Now you do 636 times 2 gives you 1272, and you subtract it from 1596 gives you 324. 324. So I'm gonna use this actually. Let me write this over here. 1596 is equal to 636 times 2 plus 324. Alright? So we bring this, of course. Our divisor now becomes our dividend. 636 is equal to, bring this over here, 324 times what? So you do 636 divided by 324. Gives you 1 point something, okay, times 1 plus, you now do 636 minus 324, gives you 312, right? Then you bring this here, 324 will be equal to, bring this here, 312 times, of course, times 1 plus 12, right? I mean, this one you can easily say it. Okay, you bring this here, again, 312 is equal to 12 times, so you do 312 divided by 12, 26, 12 times 26, and it gives you plus 0. So you see 0 is now the remainder, and that divisor there is 12. So your GCD becomes 12. GCD of that becomes 12. Okay? Now, if you want to just quick summary of this, we see that our GCD of 9888 6060 is equal to GCD of 6060 3828 is equal to GCD of 3828 2232 is equal to GCD of 2232 1596 is equal to GCD of 1596 636, okay, is equal to GCD of 636 324 is equal to GCD of 324 312, okay, is equal to GCD of 312 12 is equal to GCD of 12 0, which is equal to 12. Now, you must not put 12 0. I mean, if you want to, that's fine. If you want to do that, that's fine. You can stop right here, 3, 1, 2, 12. Then is equal to GCD of 12 0, which is equal to 12. Let me finish this because I don't want folks to say they're confused. So this will be GCD of 3, 1, 2, 12 is equal to GCD of 12 0, which is equal to 12. Now, if you want to stop here and write 12, that's still okay. That is still okay. It doesn't matter. You notice that in my 2 other examples I didn't write the last one. It doesn't matter. Okay? You can write it, or you might not write it. That's fine. But the main thing you need to know is that the remainder here will be 0. When the remainder is 0, find the divisor there, and that gives you your GCD. Okay? Now, before I go, I will just write a quick code, a quick computer code, how you can probably run this on your computer. Now, I told you in my first video how you can check your work to see whether you're correct. Make sure you do that. In the first video I did, I told you how you can check your work. Go to my website, click on Math, scroll down there and click on the GCD calculator. Put in your numbers and it should work. If it doesn't work, contact me, okay? If it doesn't work, contact me. All right, let me quickly, for those of you that I know that are computer science majors or IT majors, probably you like codes. So let's look at some code here before we finish this video segment. Let's say given 2 non-negative non-zero integers, A and B. And this is going to be our input actually, our input. 2 non-negative non-zero integers, A and B. And our output will be what? GCD of A and B. That's going to be our output. Okay? So let's kind of see what this will be. If you write a code on this. We have our GCD. Let me use here. We have our GCD. I will leave that to cover. GCD of A and B, right? Now we want to, first of all, make A the largest. You know, that's the first thing you want to do. So let me write a comment. I write my comment. Make A largest, the largest of the integer, of the integers. Make A the largest of the integers, right? So that's just the comment sign, okay, in C++. That's just the comment sign. Now, if A is less than B, right, you want to swap A with B. You swap A with B. Okay? Then let's put a loop here. Let's write a loop. While our B is not equal to 0, that's a while loop. Right? Your remainder arrow is equal to A mod B. Right? Your A becomes B. Remember, A becomes B and B becomes R. Remember that the main thing with the Euclidean algorithm is that GCD of A and B is the same as GCD of B and R. This is the main thing about Euclidean algorithm. Where if R is equal to A mod B, and we kind of talked this about the modulus, the remainder after you divide, you know. Okay, so while b is not equal to 0, r is a mod b, a is equal to b becomes r, right? Then you want to, you close this and you want to return a. Return a, actually. Because, you know, you keep on doing this thing until r is 0. Until r is 0. And when r is 0, like when we had that, when we had the last, what was the last one we had? When we had that last one, 12 plus 0, right? And you had to return 0. That you have to return a. When you keep swapping this, when you now see, it will run like a loop until the remainder becomes 0, right? And then you return a. When after returning a, then you can close the program. So try it. I mean, try it. Try it. Okay, try it. This thing. All right. Thank you so much for listening, students. I'm planning on doing videos on inverse modulus, and also solving equivalent modulus. So watch out for other videos. Thank you very much and have a wonderful evening.